I think we're pretty close where we were yesterday. So we'll go ahead and get started up today. Um, Plan for today is sort of pick up where we left off yesterday. The three topics that the big topics that I'm covering that we talked about restructuring and transforming yesterday, data cleaning, and then data linkage, which we'll talk about today as well. They're intertwined, so kind of split data cleaning off from restructuring yesterday, but it's important to keep in mind that they usually go hand in hand. Sometimes you have to do some restructuring before you want to clean. Sometimes you need to do some cleaning before you can restructure, and so forth. So although these are distinct presentations, they really are one in the same common stream or process. From yesterday, does anybody have any questions? Went home and thought feverishly about restructuring and transforming data. It does not appear that there were questions. So I either did a fantastic job or you knew it already. Probably knew most of it already. Today, we're going to dive into data cleaning. Structure will be pretty much the same. I've got a couple of slides I want to walk through conceptually. Then R should be active and operational today, which then we'll grab a piece of code and walk through like we did yesterday, but you should be able to run and modify on the fly if you want. Then we'll definitely take a break at some point between the big topics, but we'll come back and we'll pick up with another short presentation of slides on the concepts behind record linkage and dive into some R code to do those sorts of things, which gets a little bit more involved from a mechanic standpoint, but I have a lot of walkthrough show points where we'll actually take a look at what certain pieces or blocks of code are producing on the fly. So it should be pretty engaging and interesting, I hope. I find it interesting. Okay, so data cleaning. You guys have probably heard this before. There's an open estimate of how long you should spend on data cleaning relative to the full term of the project. Numbers range all the way up to 80% of your time will be spent on data cleaning. Most people view it as a necessary evil that has to be done. But realistically, it's why you get out of bed in the morning. The excitement of cleaning a brand new system of data, finding all of the riddles, tricks, oddities, questioning why people would do things they do. But it's, to me, an enjoyable experience that actually puts me in a connection with the data system I'm working in. Through the cleaning process, pretty much figure out all the odds and ends that are in a particular system, able to address questions, start thinking ahead of how you're going to use the data and what other things you might need to consider along the way. That can impact the choices you make during cleaning. It can also impact things that are going to happen down the road. So why bother cleaning data at all? Quality. It's really an issue of quality. Data systems that are collected rarely ever are in pristine condition. Some are much better than others. Some are absolutely miserable in terms of the quality in the data. As part of that quality assessment, we need to think about usability. There's always going to be some slight things to modify or fix or change or deal with. Question is whether or not, as you're working through the cleaning process, is there something in the data set that is so badly misrepaired that it can't be fixed that it renders that particular data stream unusable? Alternatively, can you creatively come up with a way to fix it without changing the nature, the intent of the data, but still have it be usable for your end application? Last important point of cleaning is standardization. No data system ever seems to yield two files that are exactly in the same structure. So there could be issues with alignment. There could be issues. We saw column names yesterday. We might see that again today. All those sorts of things, missing columns. When you're requesting data, it is notoriously the case that you're going to make two requests, something gets missed. So what we're trying to do is standardize across system files. So as an example, we have a state agency that we work with that collects home visiting data. And in some of those files, they included a column for gender. In other files, they did not. And it turns out that they simply didn't enter it or collect it in the other files. So standardization. The key with data cleaning then is really the end use. What are you going to do with it? You can clean it and just have it sit there. It's sort of a waste of your time, but also a great practice endeavor. Typically, we want to do something with the data. And so in my case, much of what I mentioned yesterday, much of what I do is work on linkage of data, connecting and comparing data sets across systems. If we're working on an analysis problem, having clean data, that is what bases your conclusion validity. You don't want to go report differences, relationships that only exist because the data is misaligned, strange, odd, something's coded incorrectly, and so forth. And the real key from a public good perspective is decision making. You don't want partners, stakeholders, agencies making policy decisions based on information that we as data scientists give them that is completely inaccurate. So those are the things to always look forward to. Is what you're doing going to hit your end goal, any analytic goals that are involved in a project? And at the end of the day, are you producing information and decision points that are accurate? Typically, the first time I ever encounter students, we start talking about data cleaning. Well, I pulled the data from this source and they're the final data. They're already clean. I don't have anything to worry about. I have never seen a clean data set, even data I've entered. I always make mistakes. Human errors happen, and humans are inherently involved in most data entry, maintenance, pull processes. Workflow errors happen. Not uncommon for mistakes to occur because there's more than one person dealing with the data. This is a made-up example of a long record, a birth record, for example, where we talked yesterday that that's a single identifier stream. You shouldn't have two records in a birth records index for the same individual. People can have the same names, people can have the same birth dates, people can live in the same towns. People can, on the surface, appear to be the same person, even though there's two individuals. They got the same name and birth date, same city. As you're kind of scrolling through this, you keep going and you see that, okay, this individual born in the same state, in the same county, this is two people that we're actually talking about. They were born in the same hospital on the same day, named exactly the same. Their parent has exactly the same name, same birth date. So it's becoming less likely that this is two different people. Look down at the bottom row, their residence county. Okay, so they live in a different county from where they were born in, but both of these individuals, if it's two people, moved there to the same city, they live on the same street, but apparently in a slightly different apartment or unit. And then this is the one that always tips me off. They weighed exactly the same number of grams when they were born. So clearly at this point, you should be doubting these are two separate individuals. And sometimes we get lucky enough that we're provided information that we don't necessarily need, but is part of the data pool system. So we might have a system entry timestamp. And if you look at that, you see that same date, separated by about an hour and some change, and happens to fold over what would typically be a lunch break. So it's entirely possible that two people were involved in entering this same single record. One did it right before lunch, took off, came back, somebody else picked up record entry, and nobody took that one off the top of the pile. We don't know that's the case, but we try to accumulate as much evidence as possible to determine whether or not these could be two individuals who are just incredibly similar, more so than you would expect by chance, but maybe they are. It depends on the sorts of information we have available. Again, Computer errors happen. Final data are never clean. Rumor has it that the computer errors that do happen are because we cause them. I don't believe that. I've seen computers do things on their own, of their own volition. I'll show you an example in some code later today where a computer decided to make a mistake for me. But this isn't uncommon. And these sorts of things, if you're kind of scrolling through here, you quickly see that about a third of the way from the bottom, everything's misaligned. There's some entry that doesn't have any immediate indication of what it would be. Everything seems to be pushed. Some numbers don't match. Line appears to be split over 2 records. These sorts of things happen all the time. Typically, there's something that goes wrong in the pull from the data provider. So we might get an educational record system where something wraps like this, and all of a sudden we have a student, an individual, showing up partially on multiple lines. So step 1, you're going to clean the data. Look at it. Look at it closely, visually inspect it. If you have a CSV file, open it, scroll through it. If you have some other sort of file, an HTML file, look at it. If you have an actual data set from a data system or a data software, open it and look at it. And start documenting. Get a piece of paper out if you have to. Whatever documentation method you're going to use, start writing down what you see. So these data, we open this file, and immediately see there's an ID number. Fantastic. Take a quick scroll through visually. Doesn't look like the IDs repeat. That doesn't mean they don't. There's a lot of more records that we're not viewing right now. Date of birth, we look over real quick. Hey, there's a missing value. Make a note of that, that they're not completely observed. What format are they in? Okay, it looks like year, month, day. Are there any really, really weird years? Doesn't look like it here, depending on the data system. So that bottom row, 1930, that could be legitimate. But if we were looking at a set of data where we knew nobody in the file should be older than a certain age, we would immediately raise a flag about whether or not birth dates are going to be accurate. We have first names. Do they look reasonable? Are there any weird things in them? They don't look too bad here. On our last names, how do they look? They look okay. We start to see some things, and then we get down to the bottom and we see some messy things. This is something we would immediately note. Potentially, if it's early enough and these came from an external system or an external stakeholder or partner or agency, we might question this. We definitely would go from this initial file, backtrack anything that we've done. Was this a corruption when we opened the file? Is there a way we can fix it? If not, can we track back to the original data before we received it and see if the same error is in their system or if they can fix it, clean that up. So we had this initial look, we started some documentation. We know there's some things we might need to clean up, definitely some things we want to dig into a little deeper. Second step, look again, and this time look more closely. Start rolling through the data, start looking at parts of it. And this has actually really happened to all of us over here in Iowa a couple of weeks ago. Quickly, this is just a demographic inventory of cities here in Iowa. And so we have our census estimates of population in each of those cities. Decennial census in the M column there, and then estimates moving forward and a couple of estimated years going backwards. And as you kind of walk through, you see a geocode ID, one's missing. That might initially get you to go, okay, there's a problem. Not necessarily, this requires a little bit of background, but we have towns in Iowa that cease to exist. They're small, they disappear, everybody moves away. So this is not necessarily unusual, but it is something to potentially dig into a little deeper. As we're looking at population counts, again, being from Iowa, it was pretty easy to catch this, but if you're not, you might start carefully walking through. Okay, well, it looks okay, not really seeing huge problems. Keep documenting things though if you do see oddities. So you might ask about that missing geocode. You might question that further, dig into it. But as you dig deeper into the data, even not being from Iowa, I think most people know that Des Moines is the capital of the state. And based on these data, Des Moines has a population of just about 5,000 people in 2012. But a town called Denver, Iowa, that I had to look up on a map, and I've been here for 20 years, has 200 and some odd thousand residents. Sort of unusual. And as we start backtracking, if we look through those estimates before 2010 or up to 2010, we notice a shift. We notice that Denver had about 1,700 people, and then all of a sudden, hundreds of thousands of people moved into town. Des Moines, capital, had just over 200,000 people, and somehow 197,000 went missing. Migration's not that severe here in the state of Iowa. As we scroll a little, this is kind of a chopped up file, but as we scroll down a little bit further, we notice similar types of inconsistencies. Things appear to be shifted if we're trying to follow longitudinally. And so in this case, we've spot checked the data. Confirmation, if this were a state I'd never been in or a place I'd never been to or heard of, I would look, what is the actual population or what was it in 2012 for Otho, Iowa? Do my numbers match that? Are they even close? Here, you've now extended your documentation into, we have a structure problem more than likely, definitely some data inconsistencies. So this same file that we were just looking at, if you scroll all the way to the bottom of it, there's 6 or 7 rows that don't have any data for the later years. And it turns out that there are about 6 or 7 towns that disappeared in this same file that don't have that geo ID code. And so what it looks like is everything just sort of shifted down. And what happened is that early on, there was a shift from 1 row. A little bit later in the file, the data shifted 2 rows down, then 3 rows down, all the way up through 7 rows down. And so at this point, we went back to the source, and it turns out that half of these, one subfile of these data had a double header row, and that started spinning things down as you went. So, decision time, these are the data I have. Are they fixable? Sure, they're fixable. Might take a while, but we could definitely go through and figure out where things went off the rails, try and restructure that and reconnect it. Is it usable? Currently, we wouldn't want to use it in the format it's in now, but if we fixed it, it would seem to be usable. We would still have some missing ID codes here, but they don't have population in these years anyway. Those towns have ceased to exist at that point. So Athelstan actually, I believe, ceased to exist in 2004. So yeah, the data would be usable. The last question to ask is it worth it? Is it worth going through the time and effort it will take to fix these the data for the purpose we're using it for? If this is a key piece of information or a key source of data, that decision is going to weigh more on spending the time to fix it versus if it's a piece of data that we could easily capture somewhere else, get the same data, we might decide it's not worth cleaning this file and just move to a different avenue. Sometimes those are decisions that are hard to make, and sometimes people disagree about those decisions. So if it's fixable, if we've made that decision, we decided, yes, we can repair this, then we apply a correction. That correction could be to repair things. It could be to remove things. In this case, we might do both. We might repair the offset rows, but also remove the lines that shouldn't have any data anyway. That correction, whatever course you take, develop, or pursue, is then going to involve an order of operations process. An order of operations can be very simple to very complex. Something we deal a lot with here in name fields or suffixes. And they run the gamut from junior to second to third to fourth, sometimes eighth, senior, esquire, all sorts of suffixes. We typically, for our end purposes, don't want them. They noise up our name fields. So we split them off. We just take them, pop them off. And so you might write a piece of code, and I'll show you one a little bit later that does this, where we're just going to split off double I's, triple I's, junior, senior from name fields. If we run a piece of code this way, the order of operations is not quite right. It's going to follow that order and take out both of the double I's anytime they're encountered, which then leaves us with people who just have an I if they had a 3. Run into similar problems with Roman numerals that go past 5. Order of operations, and this can be an issue that gets incredibly complicated depending on the amount of cleaning that needs to be done. You might correct something and then downstream realize that it needed to not be corrected until much later in the process. So there's often return loops in the cleaning process, depending on the nature of the data you have. Verifying your corrections. Different sources seem to suggest that verification is sort of an optional step. I think oftentimes we make the assumption that whatever correction we applied worked as we intended. That hopefully is the case. If you thought it through, right, wrote the code correctly, the code was executed correctly, then your correction should have worked. In my experience, the perfectly thought through correction that is perfectly executed almost always breaks something else. In terms of stripping out suffixes, for example, we might say, well, we're going to get rid of all the fourths, IB. Great, we can check. John became John. Fantastic, that's what we intended to do. But then if we go a little bit further in our verification work, we all of a sudden find out that Olivia no longer exists. Ivan, he's now Anne. All sorts of other problems can arise. So for me, some people gloss over verification of corrections. I am a checker. I am meticulous about checking everything I apply to make sure that I didn't break something down the road. And in this process, documenting everything along the way. This helps build an order of operations process for the next data stream. So if I applied a correction that caused Olivia to become Olia, definitely documenting that, making a note. That's something we need to consider moving forward and adapting code and correction processes for. Cleaning categories, we talked a little bit about restructuring transformation yesterday, about recoding and sorts of things like that. Standardization is always necessary. Different codes across systems. Gender is a perfect example. In many state systems that I deal with, it's a letter. In other state systems, it's a number, sometimes a full word, other times combinations of both. And in those situations, gender, of course, is not the only thing that works that way. We want to be able to standardize across systems so that the code means the same thing all the time. We're not altering the nature of the data, we're just making it consistent across sources. Changing codes, I think you've heard this a little bit before, not just from me, but earlier last week, late the week before. Coding systems change within a data source over time. Invariably, we've talked about potentially adding new classification codes, reducing old classification codes. One of the ones I run into quite a bit is we haven't reduced or eliminated any classification code, we've just renamed it, which then alphabetically gives it a new number. So all of a sudden, all of my people who were in category 4 in 2012 are now in category 7 in 2013. Nothing's changed. They're still the same race, ethnicity designation, but we've changed how we've labeled category 4. We want those consistent over time. And typically in those situations where something has changed and it appears to be a relatively permanent change moving forward, you have the decision to make of whether you need to be backward compatible or if you want to be future compatible orientated. That may depend on what you're doing with the data and how you're going to be using it. The other place where this pops up all the time is when collection changes. Questions, assessment items, columns, they get deleted all the time. New things get added, particularly prevalent in the data I work with, where there are assessments that change from year to year or sometimes from visit to visit. Even birth records, the system we deal with here in Iowa, they measure a series of birth risks and complications during the birth. And some of those just stop being assessed after a certain point. The issue there is that what you end up with oftentimes is a lot of data that appears to be missing, but it's not really missing. It's just not collected anymore. That can be an open question about what you do with those data as well. Do you repair them? Do you fix them? You definitely document what's happening. But again, the question is whether you're moving forward where the item might not be collected anymore, or if you're going to be working retroactively where everybody will have the data. Numeric values, we talked a little bit about transformations yesterday. Primary thing we're looking for with numeric values when we start cleaning is whether they're outliers. Are they out of range? Outliers have a connotation of being impossible values. Sorry? Oh. Outliers have this connotation of being impossible values, that they're extreme and it's likely an error, missing value codes that are 99. That's not always the case. There are extreme values that are real. And so that's something to consider. Just because your cleaning, your initial screening and cleaning routine identifies variables or values that are out of range, are they real values? They might not be, particularly if you know that there's a limit on the values you should be seeing in the data. But in other circumstances, a particularly high or particularly low numeric value could be a real data point. On the reverse spectrum of out of range values are distributions that are truncated or constant, no variance at all. An example of this is getting data from a particular point in a data stream where all the data is collected on one day or in 1 week, where you know that your span of time should be covering a much wider band than that. I'll show you an example of that a little later today. So we look for distributions where there isn't any variability. There should be some, but we're only seeing birth years in the same year over time. That would indicate there's a problem. And then back to this idea of missing values. Oftentimes they're treated as just one big annoying blob of problems, things we can't do anything about. There's some differentiation between missing values, and I think they're important differentiations. Oftentimes we see missing values due to a skip that's imposed. So there's no data in a particular column because there was a response or an observation or a value recorded in a column preceding that made that first column irrelevant. There is no score or value that's applicable because of a response or a value in a preceding question. Sometimes, and if anybody's ever worked with diagnostic assessment tools, particularly psychological assessment tools, skip patterns can be incredibly complicated. Depending on how you've responded to 26 previous items, you may not have any data for 3. So tracking those is important so that you know, and anybody who's going to use the data knows that the data are missing in a particular column because they should be, they have to be. This ties in a little bit with non-applicable missingness, and not the NA that R throws in there all the time by default, but the non-applicability of a particular item. Sometimes, again, this is related to skips usually, but it might not be a skip based on a response. There might be questions that are not relevant for people under the age of 65. There might not be things that are recorded for people who are under the age of 2. So it's not that they've responded in a certain way, it's that there's a characteristic about them that precludes a response in another column. That's important to know for end use as well. And the last distinction is the distinction between whether or not the response is a don't know or a refusal. This is less so an issue with things like administrative data, but if there's assessment data that's involved, where people are responding to a survey, whether that's a paper survey, an in-person survey, a computer-assisted survey, a web survey. Don't know responses are generally substantively different than refusals. A good example of a don't know response is asking somebody to tell you their dollar value total income for the last year, taking into account salaries, wages, tips, capital gains, gambling winnings, but then also subtracting out property values, taxes. Nobody can come up with that answer on the fly. And so typically you will see a lot of don't knows. Alternatively, asking somebody to give you a dollar amount of their total net worth often results in a refusal. People typically on the high ends and low ends of distributions don't want to answer that question. And so what you have is apparently two evenly missing values, but they're missing for very different reasons. It's not the case that people weren't going to tell you what their income was, it's just they couldn't figure out the math in their head on the fly, versus another subset of respondents who just simply aren't going to tell you. So it's an important distinction. The crux of all of this with missing data then comes to the point where you've made a decision to repair it or to fix it or to otherwise handle it. It's always a question about whether or not you should fill in data. And in this particular instance, where you have a skip, you might be well justified in filling it in. If there's a count following the presence or absence of something, and somebody said, well, it never occurred, well, then we know that their count of the event is 0. So we could fill that in. Again, you would document that and consider down the road implications of that choice. Alternatively, with things like don't knows and refusals, we get into a broad class of things that we won't discuss in detail, but essentially data imputation. Are you going to fill it in? There are a number of considerations related to imputation that are both problem specific and more generally system specific. For example, I deal with a lot of state agency data. I would be very hesitant to propose filling in data that is a legal public record or a legally binding record. So oftentimes filling it in may not be a possibility. Dates. Dates are a blast. They're important, but they come with their own set of oddities. Formats. Date formats, I know you guys, at the beginning of all this training, your best practices on how to set up your dates. That was great advice. Standardization. In my work, I typically like to parse dates into separate fields. There's a reason why that I'll get to later this afternoon. We know that we could also standardize in a much more global convention of year, month, day, rather than month, day, year. But typically dates don't come through clean enough or in a format that's easily switched around. Origin dates. Every system, no matter what system it is, has a way of storing date information. Here are a couple. A little pop quiz for folks. Do you know where these origin dates go? Where are they tied to? What software? Anybody know what program uses January 1st, 1960? You throw it in the chat. Let's see if you... Nobody's gonna guess. Okay, so January 1st, 1960 is actually the anchor or origin that Stata uses. It stores dates in the number of days from that date, both positively and negatively. October 14th, 1582. Anybody know what program uses that as an origin? Program not used probably by a lot of folks nowadays, big in the social sciences. It's SPSS's anchor. And SPSS actually stores dates in the number of seconds since that date, midnight on that date. No idea why they chose that date. Frustrating that it's in seconds. You always have to add 86,800 to everything you compute so that you can cancel out the seconds in a normal year. December 30th, 1899 is an origin date. Anybody know what program uses it? Nobody's gonna guess. Thursday afternoons. Excel uses that as an origin. That's what it bases its formatted dates sequences off of. January 1st, 1904. Anybody know that one? That's also Excel if you're using Mac. So Excel actually treats dates two different ways depending on which version of Excel you're using, which can be phenomenally frustrating. There is a simple trick to this though. If you ever get dates that are in a format that is not a date, so typically if something goes wrong, particularly with something like Excel, you'll get just a digit sequence. Put your own birthday in and see if you get it right, applying either one of these origin dates. That's my quick trick. So this is, like I said, in column F of the picture next to it, this is typically what you see when a formatted system date loses its formatting, leaving that system. It's not uncommon to get dates in these numeric sequences from things like Excel if the data were pulled in Excel and then transferred to a CSV file. This happens if there was an internal format applied to the Excel file. Simple to fix, as long as you know, you have an idea of which one of these origins is going to be the right value. Invalid entries, months, we think about distributions again. We know that there are 12 months. What should the distribution of months and dates look like? Well, it depends on the system we're working with. If we're working with birth dates, we would assume then that that distribution should be relatively uniform. There's no great likelihood of being born in May, more so than being born in October. Days, again, if talking days of the month, distribution should be reasonably uniform. The old adage of how many months have 28 days, all of them do. So we should see a relatively uniform distribution, except for 31. Not all months do have 31 days. Year distributions. They too should seem reasonably uniform if we're talking about something like birth dates. They may not be uniform if we're talking about something like enrollment periods. This could depend on cohorts. If you're dealing with a birth cohort that is only 4 years, then the uniformity in the distribution should still be there, but that uniformity would be truncated to only 4 options. Alternatively, if you're looking at birth dates for something like an educational record system, there are cutoffs. So you might see truncation on one end or the other, where children have to be born before a certain month in a year to be enrolled, or they can't enroll after a certain month and year. And so now you might see truncation on the ends of that year distribution. Things to note, things to look for. I'm going to move forward. Another issue with dates that I think gets overlooked sometimes when people are working with them is this idea of multivariate distributions in dates, or more appropriately from a statistical standpoint, conditional distributions or bivariate distributions. What are the most common dates you should be seeing in a particular data system? Anybody want to take a shot at what the most common birth date is? There isn't one, theoretically. The odds of being born on any given month and day combination should be reasonably accurately even over time, unless of course we have some sort of truncation again. Least common dates, there are some. This has an answer. What is the least common date of any given year? Well, it's February 29th, assuming you have at least 4 years of data. And now somebody chimed in. Exactly, February 29th. What if your data system that you're working with runs from 2013 to 2016? Is February 29th in there? Maybe, maybe not, depends on how far the data go. So if we don't have a leap year in the system we're working in, February 29th would indicate a problem. Impossible dates. Along the same lines, which dates are impossible? It's the date my watch always reads on March 2nd. I never set it ahead, so it always counts February 30th, February 31st, and so forth. So I'm usually 4 days behind by the first week of March. Impossible dates that don't exist. Suspicious dates. These are, again, system specific to some degree. Again, my systems that I work with often have the possibility, some of them, of prenatal enrollment. So you might be it might have people signing up or enrolling in programming pending the birth of a child. And what you tend to see sometimes is that rather than leave fields blank and just indicate that the child hasn't been born yet, you get some overzealous data entry folks who just go ahead and put in placeholders. January 1st is incredibly common. Think back to the most common dates. Should January 1st occur with incredibly more frequency than any other date? Probably not. This can happen around enrollment deadlines too. All of a sudden you'll see a whole bunch of enrollments on September 15th. Well, because you have to enroll by September 15th to be eligible for programming or class enrollment or daycare or preschool by that date. Differences in dates. This again is taking a multivariate look at a date. Compute the difference between them. If it's a home visiting file, there's a record of each visitation date. You can't go backwards in time. Alternatively, you probably wouldn't have 2 visits 1 day apart. Might have visits separated by some time, but let's suppose that this particular system, based on these dates that are here, you might expect a visit around every 30 to 45 days. What if the duration between 2 dates is about 390 days? We might make a note that there could be an error in the year, that another 365 days is being added in. So consider things out in both their univariate or isolated sense, but also in relation to the other variables you're cleaning and assessing. Sorry, my button does not want to work. Names. I spend a lot of time with names. My work is centered primarily on name fields because of what I'm doing with the data, but I want you to think more generally about any text strings, addresses, notes, web scraping actual text. There's a ton of work to do to clean those sorts of fields. And a first step in cleaning those fields is to standardize them. As you're well aware by this point, particularly after the other day, a small or lowercase letter is not the same as an uppercase letter. They are treated differently, so standardize things. Upper or lowercase is sort of irrelevant. You can make that choice. Just be consistent across your systems, because the comparisons just become incredibly difficult if you're also fighting the noise of a capital A is not being treated the same as a lowercase a. Names again, or text, addresses. How many fields is the information in? Names, we might think there should be maybe 1 field, name, first and last. Okay, great. Oftentimes there are 2 fields, first in 1 field, last in another field. 3 fields, 4 fields, 6 fields, on you go. So much so that you could have name data occupying multiple rows or columns of data across the system. Whoops, sorry. Thought somebody said something. Once you determine how many fields or columns your text information is in, the next question is whether or not the fields are consistent. Are names always in the format, if they're in 1 column, of first comma last, or last comma first, or I typically deal with both in the same field. We have last name comma first for some entries, first name comma last for other entries. Fantastic data entry that is a joy to clean. We also might have 2 fields, and run into very similar problems where there's first and last fields that contain first and last like they're supposed to, last and first like they shouldn't, any combination of those sorts of things. And so you can see that in cleaning the data aren't missing, they're there. And this isn't a structural problem, this is an entry or recording problem. Is it fixable? Yes. Is it worth it? In my case, yes. So I spend quite a bit of time dealing with these sorts of things. In addition to weird things like format problems, inconsistent use of fields, extra information, 9 middle names, 6 first names, all those sorts of things that happen, there's unusual stuff that shows up in names and text. Numbers, this is incredibly common. Sometimes there's a decision to make of whether or not those numbers are reflective of suffixes. They might be, particularly if they come at the end of a name. Alternatively, other times we know they're typos, that they're just, somebody missed the E and they got 3 twice. So we have to correct those out. Punctuation. Commas, yeah, that works. Apostrophes, no problem. Hyphens, sure. All good and dandy until you get to just this sort of stuff. Semicolons, apostrophe, or sorry, at signs, colons, semicolons, quotation marks, brackets, parentheses, all sorts of things. And keep in mind that if I'm dealing with this and I need those names, particularly for a comparison to another set of names later, I'm probably not going to get lucky that somebody hit an @ sign twice in Shane Barron's last name. I've got to deal with that somehow. Placeholders. This happens way more than I would hope to. Again, talking about systems that might prenatally enroll. Rather than leave those fields blank, they decide to give us things like baby, twin A and B, child 1, baby girl, baby boy, no child, no name, unyet named, undetermined, not known. Those are all things I've had to encounter and deal with in name fields. And then the last kind of unusual stuff are those things that we started with. I don't have a solution to those yet. I'm working on it. Basically, at this point, they're not going to align with any other system I get. I won't see the same encoding error. If you happen to be aware of a way to fix those easily, I'd love it if you send it along. Problematic. Luckily, they don't occur all that often. So, data cleaning, the general idea of data cleaning. Any questions about the concepts before we dive into actually doing some data cleaning?
Hey Todd, I think I kind of missed the part where you were explaining the significance of origin dates. So how does that affect our algorithms? Like what is the significance? Can you please repeat?
Yeah, that's a great question. So again, it doesn't happen all that often. And sometimes if it does and you know what program generated the data, it's really easy to fix. But I've encountered a few instances where there's an intermediary step before I get the data. And so what'll happen is it'll come out of a system, somebody will format it in a software package and then transfer it to a format that doesn't have built-in formatting. And so a date will turn into a random string of numbers by the time I get it. And so then when I have this random string of numbers that's supposed to reflect a month, day, year combination of some sort of date, knowing what those origin dates are, you can go in, actually Lubridate has a way of doing this pretty simply, where you go in and tell it what format you want to convert the text string to, but you supply the origin date. And that will convert it back into an actual date rather than, as I mentioned, some programs are a little crazy with thousands of placeholders. So if you're talking seconds over the last 500 years, that's a huge long number that isn't going to resolve to a date without some information of how the dates are stored in other programming. Does that make sense?
Yes, sir. Thank you.
Great. Any other questions? All right, so let's take 10, and then we'll come back and we'll fire up some R sessions, which should be running today, and we'll do some walkthrough on some data cleaning with some code. So let's be back about 2 after noon, and see everybody back. There we go. All right. So as I mentioned, if you're just getting back now, go ahead and log into Ravana and initialize an RStudio session. See if we can do that successfully today. And then we'll take a look at some code and run some cleaning stuff. Same place as yesterday in terms of where to pull things from. So I'll drop the GitHub repo link in chat. As soon as I figure out where chat went, there it went. Okay. Wrong person. Sorry about that. Everyone did that yesterday too. There we go. And so the same place as yesterday. Today, you're gonna be looking for an R script that is just titled Data Cleaning DSPG 2020. So I'll drop that in there too. Share that one. All right, so you should be able to see my R screen now, hopefully. It should look like this for you. And so a couple of libraries will load data table, Luberdate, which I think you guys have had some experience with already, probably. And then I know Stringer, you guys covered a little bit on regex the other day. That's that same package, so go ahead and load those in. Those are the 3 we'll be using for this part. The data, again, don't worry about it. I set to my desktop. You don't set to my desktop. You guys set to where you need to set. The data set is that data cleaning DSPG 2020 CSV file. So we're going to read that in. One important piece here, as you're getting ready to read in the data, you'll note in my FRead statement that I've got column classes set to character. This is actually on purpose. What I want to do when I'm cleaning data is I want to bring it all in as character strings, everything in the data set. I don't want number formats to get convoluted. I don't want factor variables to be created. I don't want dates to be modified. I don't want anything to happen. I just want to bring in everything as a text field. And the reason for that is, one, there's a lot more you can do with text to repair things. And 2, those sort of structure issues that we looked at where rows get misaligned and things get twisted, columns get moved, that doesn't seem to have as much of a downstream effect on other columns if everything's being read in as text. And so generally when I work in a new data system and I'm going to do some cleaning, I just want everything as a character string. Obviously they'll still be in their columns and so forth, but this is an intentional piece. We're going to do all of the cleaning, most of the cleaning on character strings. So if we just click that and run, we should get a data set of about 1,100 people. It's a small data set. There's only 5 variables. Step 1 of data cleaning, look at it. Look at the data. There's a number of ways you can look at the data. I'm sure many of you are familiar with these already, but you can look at the structure. Kind of pointless here because I said everything is a character string, so the structure is not going to tell us anything surprising, but it will tell us what the column names are and things like that, what the entries look like. We can look at the head or the top of the data set. We can look at the tail of the data set. We could pull a random sample of observations and look at them. And so I tend to go through this process, even though I don't really expect any big surprises. The structure of this data, I have 5 columns, so an ID of some sort, a first name field, last name field, gender, and a birth date. They're all character strings. That's good. That's what I wanted. And as I start just quickly scrolling through there, I can see that there's ID numbers, and there's first names, last names. Immediately, I now notice there's something weird in the gender column. There's a 1 and an F, male and female. Dates look like they're in date shape, at least initially. I wanted to take a look at the top of the data set. And sometimes I'll mix this in a head command or a tail command with a sort command inside. I think we saw that a little bit yesterday, so that I can see if I sort by ID, are there blanks? If I sort by last name, are there single letters that start with A? Generally though, a rough, quick head of the data, nothing dramatically shocking necessarily. For my purposes, you'll see later, I initially noticed there's some hyphenated names, there's some multiple entry fields in the name fields, things that I'm looking for. Same thing if we look at the tail, back 20 lines of data, the bottom 20 lines of data. You see things there. Again, some more hyphenated names. Nothing too surprising, too shocking. So far, so good. ID numbers appear to run a full range from low numbers to high numbers. And again, I'm documenting anything strange I see here, but also I'm looking for things I know that I run into quite a bit, things that I know I'm likely to see. Now I'm just going to take a random sample of 20 lines from the data and take a look at that, see if anything kind of snuck in, somewhere buried in the middle. So generally this data set so far, aside from some weird things in gender, zeros and Fs and ones and Ms, looks pretty consistent. That doesn't mean it is, but on the surface it looks okay. My next step then is to start looking at missing data. What am I lacking in columns? Are they fully observed columns? It's an important initial piece of information. Everybody thank Aaron. He showed you this function a couple days ago. This thing is a huge time saver. It saves you from having to write 4 lines of code to check a missing value. This is the actual function, so if we run it, nothing should happen, but you do want to run it. Hopefully it works. There we go. So we now have this function available to us. And this was explained the other day, but basically what this is going to do is scan through and return anything that is null, system null in R, strings that have no length, blanks essentially, actually anything that's got a character string with no contents. So it's looking for every possible way things could be missing. Again, just a huge time saver. So now I want to go through and start looking at each of the columns. What is there, what isn't there that should be? Yeah, go ahead. Oh, somebody. Okay. So the first thing I want to do is look at IDs. IDs are incredibly important for the work I'm going to be doing with this data. So if I click that, I get back an empty data table, which is great. That means that there is an entry in every one of those rows for CID. That doesn't mean the entries are correct. It doesn't mean that they're not the same character string. It just means that there's something there. That's one less thing I might need to worry about moving forward. Here I'm combining, I mentioned I'm combining order commands with head or tail commands. Now I do want to sort those IDs and take a look at them. So now my IDs are sorted. Again, these are text strings, so be prepared that if I'm sorting numbers, I'm going to see some slightly unusual things with regard to 16 coming before 20 or before 2. Text strings are being evaluated as text. Here, I'm just curious about what my minimum range might be and what my maximum range might be. Oddities, so if this was just C-1, I might be very concerned that that's not consistent with the other IDs. Again, now I just want to look at the bottom. There's same numeric precision, so there's still 6-digit numbers following a C and an underscore. So far, so good. Again, I don't know that these are individual IDs, unique IDs, that they don't repeat. All I know at this point is that they're fully observed and they appear consistent. My next step then is to see if they're repeated. So I'm now just requesting a show of duplicated values. And because these are text strings, they have to be exactly the same. So if there's a space somewhere in there, in one ID. So I have, let's say I have C-_991 space 475. That's not going to match that ID. There's like a little bit of a level of precision, I think, with strings that you can take advantage of in some situations. So this is just going to go show us part of the data for anybody where that ID is duplicated. Usually it's at this point I've crossed my fingers that I'm going to get an empty data table back. Here I did not. I have one repeated entry. The problem with this is that it only shows me the one that was duplicated. I really want to see the others. And so that same duplicated command, if we adapt it just a little bit in this next line and ask it to show us both from the last one that was duplicated, this will actually give us both of the lines of data that have the same ID. All right, so we get the same ID. Where this goes quickly off the rails is when that ID number comes back and it's tied to two distinctly individual people. That is a frustrating day that requires a short break to go think it through. In this case, this is a consistent record. There's a little bit of a difference in the first name field, but it's close. The last name is identical, gender's identical, birth date's identical, and the ID is identical. So what's probably the case is that there was some sort of record entry duplication, or somebody saw this part of the first name and thought it was another record and entered it anyway or retained it anyway. In this particular case, it appears pretty convincingly that this is the same individual just in there twice. Alternatively, if those were very different names, you'd be very concerned, trying to figure out now who belongs to that ID. Anytime you're working in these sets, you have a decision to make about potentially creating new IDs. They can be useful even if there's an ID system in place. If there is no unique identifier in place, you definitely need to make one. In this case, our IDs are almost perfectly unique except for this one row. Realize that in reality, this might be 200 or 300 pairs that are the same person. And that might be tied to a date of enrollment or a record entry date or some other piece of information. So if we want to create a unique identifier that we can use later in the cleaning process, it's pretty simple to do. We have some options. You can certainly just number rows. There's pros and cons to doing that. It's quick, but it's also not very descriptive. Depends on how you have the data sorted and so forth. My usual go-to, although not always, is to generate a pseudo ID. And so that's what this line of code is going to do. It's going to create a new variable in this data set called UID. And it's going to just paste together the letters CID and draw a random number between this range. Tack that on in the row length. So I've got 1,082 observations. That's how many times it's going to do this right here, rather than typing in 1082, just having it read the number of rows in the file. This is key. Replace being false. This will ensure that the sampling out of here does not duplicate, as long as this range is large enough. So if I put 1,000 to 2,000, this wouldn't work. Somebody would have to be duplicated. I'd get an error, but you want to do that. The separator is just because this is also going to be set as a string. So I'm going to separate CID by this number with an underscore. And the last bit of this is a random seed. Because it's going to draw a random value, different systems use different things. Oftentimes, some systems will use the time of day of the current date. Others have a preset number that you don't know. We can typically set seeds for random processes. And the reason we would do this is that if we run that set seed command immediately before this sampling command, this is repeatable. So I could come back 2 or 3 years from now, and as long as I run those same 2 lines of code together with this same file, I would get the same random IDs generated. It's a fun homework assignment over the weekend. You can try this. The seed is arbitrary. This is just some number that you feel good with. I usually use the date I'm doing things. Easy for me to remember when I did it. And as long as nobody changes that number and the number of lines in the data set doesn't change, I can come back in 2026 and rerun this and get the same thing. The key is that you want to run both of those lines together at the same time. Okay. We're talking about cleaning data in lecture slides. I'm a verifier, so a lot of this is going to be making sure it worked. What I want to know is that I didn't duplicate any of those new IDs. These are the new ones I just created. And success, I have no duplicated new IDs. The reason why I did that here is because I want to use it. I want to actually save those unique IDs, and I'm going to drop that duplicated case. So I know that individual now has this ID by running this line of code. And so this is the same thing we ran just a few lines before. You give us all the duplicates based on the original IDs in the file. So there is May Leilani again. But now these new IDs I created are different. And I'm going to use that to select which record I'm going to keep. Okay. Which one you keep could depend on a number of factors. If there's a time variable involved here, you might keep the latest one, or the earliest one, depending on the system. There should be a logical reason for doing that. Here, my logic is I'm going to keep the record with more information. I have a suspicion that because this person, just from experience, has shown up in this file with part of a name, and there's more of that name, that I might see these same pieces of information in other systems. So I want, in this case, to keep the record that has more information. Okay. So this line then will take out anybody as long as their original ID is not this new one I generated, this 515695 value. So we'll drop that individual. And we've seen we go down by one case. Fantastic. Some dates. I don't have anything else to do with ID numbers. They're in pretty good shape. So we start working on dates. First thing I want to know is how many are blank, how many are missing. So we run this is blank command on birth date. I've got 2 blank fields that are shown down here and who they belong to. There's nothing there, so I don't know that I'm going to be able to do much with that, other than I know that I'm missing 2. The question in the chat was doing it by first name. Yes, you certainly could have. It's a good point. You could have say only keep the record that where the first name is May Leilani. Except you could run in potential problems if there's more than one May Leilani. You could run into a nightmare of coding if you had 22,000 people with the same situation. Not to say that you wouldn't run into a little bit more of a complication with the random IDs, but if it's just one case, there's hundreds of ways to go about parceling out the one you want to keep. Start thinking though that if it happens once, it's going to happen more than one time. Does that make sense? Seed should work the same. Interesting. So if I go back and actually don't do this, I'm just trying something. Curious. Okay, so I just ran that again using the same code and I get the same generated second ID. So I'm wondering if there's something running on your R that is causing an issue with that. I should have closed all those long ago. Don't pay any attention to all that. We're just data cleaning right now. Get rid of all these things. All right. Anything else? Okay. I have on really strange occasions put a date in there in that set seed and had it take issue with the number. It caused some kind of internal problem with the generator. So in that case, I've like tacked on another number. Usually it works though. I've only had that happen once. Temperamental day. Generally though, this should work if you always keep the same seed and run in time. If you run lines separately or do anything after running that seed, it will not work. It will automatically reset a seed to a random point. So you do want to make sure that you run everything in exact time.
It might be worth.
Sorry,
it might be worth noting that the set seed can result in different results depending on the R version sometimes.
That's a possibility too. Yeah, it could be an older version of a package or the background that's running. I'll show you an example of that today when we get to data linkage, where something I do all the time worked fine until last night when I was doing it on a different version of R. Something we talked about yesterday, actually. So again, this is one of those great opportunities that when you do things like this, verify. Like I said, I just went through and ran it again sometime after some time had passed, just creating a second variable and got the same thing. All right. So again, not necessarily in this case, we probably didn't need to do that. But like I said, if we had hundreds of these, or if we didn't have any IDs at all, we just had repeating names, we might very reasonably want to create some way of indexing them. Okay? And again, if it's just something you're going to use for cleaning that's not going to stick around, you can certainly just do an N row count. So 1 N row and just ID 1 through 1082. Those would still be unique, right? Any other questions? Okay, so dates. We looked, we found 2 people who are missing birth dates. Okay. Formatting is dates. Okay, so I have this DOB variable. It's currently in month, day, year. If we were going to use this as an actual date, we could convert it, apply a date format to it, easily enough to do. So we click that. And we notice there's an issue. We should notice there's an issue. We have some parsing problems. So what that likely indicates is that there's some out of range information. Go back and take a look at what's missing now in that date of birth that I just transformed. And so here are our 5 NAs that we just created on the right side of the output. We know we had 2 missing values, so they should be NA, right? There they are. These are the 3 that failed to parse out. And as we mentioned a little earlier, 231 is impossible. And May 76th, I don't think has ever occurred. So we've got some data entry problems there that are going to be an issue in terms of treating dates as a whole unit. Oftentimes, I don't want to treat dates as a whole unit for cleaning purposes. What I really want to do is just split them out into separate columns so that I can use information in the month column, day column, year column to do separate things with. Here's a handy dandy little function to parse those out. And yes, this is a pretty simple thing to do if the dates are all in exactly the same format. But notice that this function is actually able to convert different formats at the same run. So I could have a mix of dates in there that are year, month, day format or month, day, year format. And it will convert them all at the same time. So it's just an efficiency step. We click run. We should have this parse function. And then what we're going to do is just use that function, parse DOB to columns, tell it which field is the thing we want to parse, what format it's in. Okay, so this is our birth date, which is in month, day, and year. I click that. We still get those same three that fail to parse for the exact same reason. It's not going to solve that problem. But what we now have in the demo data set, we have new columns of birth year, birth month, and birth day. Okay. And if we go through and now look at what's missing from the birth years, this doesn't repair those three failures to parse. So even though the 2 is a valid number and the 2013 is a valid number, it's not going to fill those. Someday down the road, I might try and get it to do that. But currently, that function is only going to result in parsing errors if the entire string is still invalid. Okay. So now, I want to examine the elements of birth date, clean them up. This can be done with simple tables. You just look at what are the frequency counts of year, month, and day. What we'd expect is some range in here. Okay, we immediately have a problem. Notice out here that this hasn't happened yet. That certainly hasn't happened yet. I think I paid my house off in 2014. This is a little low, 2001. Depends on the data. Remember I said outliers sometimes are valid. Here, if I'm dealing with a cohort of people, and these are birth records or death records or enrollment records or something where I know that these years are finite, this would indicate a problem. Probably a data entry error. These definitely are problematic. The immediate solution is not obvious to whether or not this should be 2011, 2012, nobody knows. But we definitely have three indices that we document as we're gonna have to do something with them. Months, fantastic. Looks pretty uniform across the months. There's a little bit of elevation here, a little bit of decline in, so March is a little high, December is a little low, but not dramatically so. When we get down to days, we also see some reasonable consistency. There's no numbers majorly jumping out, except maybe the first. It's a little high. It's not terribly, terribly high, but a little high. We would always expect the 31st to potentially be a little lower because there's only 7 months that have 31 days. You guys have done some plotting already. You could also do all of this sort of thing through histograms if you wanted to. There's a histogram of my days. Again, first looks a little high. It's occurring too often, maybe not. 31st, we would expect to be lower than the other days of the month. Could also look at this using numeric values. Once they were parsed in the separate columns, they will work as numeric values. They have a format that is no longer a character string. So we can actually run a summary on the days. Note that we already know we have 5 people who are missing birth date information. We know our minimum and our maximum. Typically, the average should be somewhere around 15 for the days of the month. This next option down here is actually starting to look at a 3-way cross tabulation of month, day, and year. I don't always recommend doing this. So if you don't want to cloud up your console window, don't bother running this line of code, but I want to show you where this can be useful. So what this is doing is taking every year and then each month, and then the days are running across the very top of this table. It's a big table. It can be a huge table if you have a lot of years. But where I found this to be exceptionally useful is when a stakeholder or a partner or an agency fails to send all of the data. So you might see records only running through 1 month or 2 months of a year. So you'll have hundreds of records on each of these days maybe, and then all of a sudden the rest of the year is just zeros. and it shouldn't be. And so again, this isn't necessarily always something I do, but it can be a pretty quick gauge to whether or not you're missing a giant chunk of data that you know you should have. So something to just keep in the arsenal, that you might want to look at everything in combination. This actually happened to us. We had birth records data that were supposed to cover the full year of 2009, and they only pulled January. So we had only month 1, day 1 through 31, and the rest of the year was just zeroed out. Another thing I've gotten into a habit of doing, primarily because of this placeholder idea, that I deal with a couple of systems that have prenatal enrollment or prenatal record keeping that is, I assume, supposed to get modified at some point. This is actually just going to take month and day and combine them and then list them in descending order by frequency. So if I click run here, the most frequently occurring month and day of birth in this data set is January 1st. And out of my almost 1,100 cases, 23 observations are born on that day. Not a lot, but my next most common date is October 13th with only 9. So typically, if I had generated better fake data for you, what would happen here is that at best there would be 366 possible combinations if I covered a leap year. And as you all said, February 29th would be the least occurring birth date or date. And what you generally hope to see is that there's no clear standout at number 1. Or if there is a standout at number 1, the second most common pairing is reasonably close in frequency. Okay, so if we didn't have this line, if I just had 2 and 3 as my 1 and 2, I'd be pretty happy knowing that, okay, October 13th was pretty common, but just as common as July 3rd. Again, this is a small data set. I've done this where I've gotten hundreds in relation to tens. And that is a clear indicator that somebody's using January 1st to fill columns. There's no way 10 times as many kids are born on the same day than any other day of the year. So that raises questions about, say, the validity of or the accuracy of the data in those columns, which we'll talk about a little bit later today. And so we've gone through birth dates, and we're now at the point where we've got to decide, is it fixable? Is anything fixable? We know we're missing 5 entries. Well, those 3 that failed to parse, remember, we had February as the birth month. Get back up there. February was our birth month, which is valid. 2013 is valid as a year. May is valid, and 2013 again as the year is valid. The days seem to be wrong. And so these could be typos for the 13th. Not guaranteed. This is where we make a decision. We might decide that because it's not a reasonable date, we're going to just treat it as a missing date. That's possible. Alternatively, if we know that this system is usually pretty solid or these data are pretty well recorded, we might decide that the months and the years are valid entries and we might decide to keep them. And again, that's a decision that's made based on the system you're working in, based on what you know about that system. If this was something like a state record system, I might trust that the month and year are correct. Alternatively, if this was something that was self-reported by an individual, I might not trust that the month and the year are correct. It depends on what you're actually doing with the system. If we decided to make repairs, we could certainly do so pretty easy. Here, we're just going to go ahead and replace those 2 observations that have February 31st. We're going to replace their year and their month with the valid values. And we'll do the same thing for the observation that had May 2013 that appeared valid, but the invalid date. Again, if you did make a replacement, You would have a document that said what you did and why you did it. That is key with this sort of stuff. Okay, so we fixed up our dates. We're as good as we're going to get there. We have those years that are a little outstanding. So we had what, 2021, 2041, and 2001. We would probably at this point want to make a decision about those two. We could opt to delete those, much like we've just done here. And if we did, we'd just go back and grab their dates, or we could actually just say year is 2041, or we could just recode anything over 2016 is now NA or system missing. Again, decisions to make on a case-by-case basis or in a process-by-process basis if you're dealing with the same systems over time. Okay. Categories, gender is the only one I have in here, so I want to take a quick look at it. How many people are missing, how many are observed? So I'm missing 6 folks that don't have anything in that column. That doesn't mean that everything in the columns is what I want, but we know that we have entries for at least the other 1082. Here I want to see what's there. So I'm just using a simple table command to show me everything that's in the gender column. And unfortunately, it's not as clean as we hoped. We see zeros, we see ones. Those are our 6 missing people over there. We have an F, we have the word female, G, I don't know what that is, M, the word male, 2 M's, and an N. Okay. Typically, and this again might depend on a particular data system you're working in, those are near universal sorts of codes. So obviously male and female makes sense. Those are usable. F and M being the most often abbreviated forms of those. Zeros and ones often being used to designate gender as well, or biological sex. So I showed you guys a recoding of that yesterday. The trick here is that you would have to know, did they uniformly use 0 for male and 1 for female, or the other way around? That would require probably conversation with the person who provided the data or some documentation of how this internal coding might be used. Alternatively, without any information, you might be trapped with no information to retain there. You certainly would not want to consider these all male and these all female if it's in fact reversed. So assuming that I actually did find documentation that 0 and 1 are being used for male and female, and that F and M stand for female and male respectively, I now would want to standardize those into a uniform descriptor. Okay. I don't know what to do with G, M, and N. I might make an assumption that that's male, but for one case, I'm not going to make that assumption. G could be a typo for F. They're pretty close on the keyboard. But again, this is something I can't confirm. It's an assumption, and usually we don't want to go replace data on assumptions without some evidence or justification to support the decision. So if I make that choice or the decision and I can verify reasonably that 0 is male, M is male, okay, 1 is a female, F is female, I now want to standardize those. So there's a function here that will do that sort of standardization. And if you scan the code real quick, you can see that anything else is going to get set to an O for other. So we run the function, we call it here, standardized gender, tell it what our column name is. Run that. And then verify that it did what we hoped it would do. And it did. And so it combined all of our F's, M's, and F's, females, and zeros, and all of our M's, males, and ones, all the way around. F, female, and 1, M, male, and 0. Left our 6 missing folks missing, and then put everybody else into an O category. Other, this could be NA. You can clearly modify this to whatever other indicator or index you wanted to use. Okay. So now for the fun stuff, we'll deal with some character strings. Here I've just got first names and last names. It's not uncommon to have first name, middle name, last name, all a single column, all host of things. And the first step always being to standardize it. I'm just going to change everything to uppercase to make things a little bit less noisy. So that will just change all of the lowercase letters to uppercase. If there were uppercase letters there already, they stay that way. Now my A and my A are comparable. Everything is happy. The next thing, following the pattern, you should be seeing the process now. Standardize, look for missingness. So I want to see how many people are missing first name, if anybody. And I have one. I have one person who has a blank in that first name field. In their last name field, they have 4 names. It looks like Edward might be a first name, and De Los Santos is more than likely the last name. Okay. Looks like something may have not necessarily shifted structurally, but somebody may have made a data entry error in inserting the entire full name of the individual into one field. I want to do the same thing with last names. I want to see if any of those are missing. And in fact, I have the same problem in reverse. It looks like I have 2 people who are missing last names, but they have names in their first name field that look like first and last names combined. Sometimes this isn't easy to figure out. Sometimes it's relatively obvious. There's always some uncertainty. So again, you have a decision point to make. Do you want to fix it? Do you want to change it? Do you have reasonable evidence that supports making that change if you change it? Alternatively, are you willing to just leave it the way it is and venture on? In this case, I'm going to go ahead and make the change so that this is the person's first name and this is the last name. And down here that these 2 are the first names and Noella and Soledad become the last names. Now, the reason I'm kind of basing this decision on in this data set is that it's only 3 cases out of 1,000 where this happened. So it's probably more of an entry error than anything else. If there were hundreds of cases where this was occurring, I would then probably try to get back some information from whoever provided the data or whoever owned the data. You guys sometimes use a single column to enter names. I would want some better verification than it looks like this is what happened. So here we could actually, because there's one person, make this change pretty simplistically. There's 2 people here. We could make this change pretty simplistically using string replacements or subs, something like that. But again, this is a small data set. Imagine this is a couple 100,000 cases in the full data set, and you have this problem in maybe 1,900 rows. Again, it's a very small fraction of that data set, but it's not something you would want to run or write tons of subs for. So there's a function here that actually works, and this is something that would be very useful for things like addresses. If you're working with addresses that have these sorts of problems where city and state are in the wrong fields, the goal of this function is actually to read through the text string, count the number of separators that are determined by you, and split things between the separators. Okay, so I have spaces here. I could have commas, I could have hyphens, I could have any other thing in here. But what that function will do, if I specify it to get between separators, I could say get between spaces. It would take DE from Edward De Los Santos out of there. So if I run this function and load it, so we now have it available to us, get between separators over there. I'm now going to take that first one, Edward De Los Santos, and using some of the things you guys learned about this week with regex, right? We're dealing with text strings. I'm going to have it go through and pull out Edward and leave everything else intact. The key is that I don't want it to do this for everybody in the data set. I don't want to take out every entry in their last name field and move it. I just want it done for ones where the field, the first name field in this case is blank. Okay? And I only want that to happen if there's a separator, a space in this case, in the last name. So that's what that first line of code is doing. The function is actually here. They get between separators. And so we're going to go through, and the last name is where it's going to look. The separator I'm specifying is a caret to indicate the beginning of the string. The second separator is the first space. So Edward is the beginning of the string. Here's the first space. I want to include the space in the output. Usually a good call. And then for the rest of the name, I want to get between separators in the last name field. The first separator I want to be a space, so space between Edward and Day. The last separator I want to be $, the end of the string. And so what this should do is take Edward and drop it in the first name field and leave De Los Santos in the last name field. So run that. Verify, did it work? Okay, so this is the ID for Edward De Los Santos. These are two others, just for comparison purposes. Randomly, sort of randomly picked. So if we click that, we should see that this person, who you have not seen before, nothing happened to them. They still have a hyphenated name in their first name field and a last name in their last name field. We can now see that Edward is in his first name field and De Los Santos is in his last name field. And remember that we had two people that had the reverse problem, where the entire name was in the first name field. Nothing was done to them. Okay, so Kristen Soledad and Patsy Noella are still all in the first name field. So to deal with them, we're going to do the exact same thing we just did, but we're going to do it to the first name field. Okay, so we want to do this only to first names that have a space, at least one, and only where the last name field is blank. We're using that same function, except now we're applying it to the first name field instead of the last name field. And we're using a caret to represent the front of the string, and the space is a separator, or space is a separator and the end of the string. So we're doing the exact same thing in reverse. If we run that, we verify whether or not that worked. Okay, so same 3 IDs, and then I added Patsy back in there. So what we see then is Patsy has now been split. Francis, Jacqueline, Abbott is still as the name fields were. Those were not altered in any way. Edward De Los Santos, that apply correction that we did has not been reverted. And then Kristen Soledad has also been shifted over. Okay. Verification becomes very important when you're cleaning. Next thing I usually like to do is check out the length of names, and the reason why. So this is just going to go through and pull out anybody who's got a name field that's less than 3 characters long. This is usually where you find fun things like initials being used as first names, TJ, single letters, all host of fun things. But there are also valid first names that have 2 letters in them, Al and he. There are last names that are valid that have 2 letters in them, okay, Lee, Wu. More of is there a problem I might need to deal with in terms of initials, or particularly if there's a whole bunch of people who just have A as their first name. 35 people that have a first name of A or B or C. That would indicate that I have some bad data that's probably not usable. And string count, here I'm counting up spaces. That's the next thing I kind of want to look at is how many double spaces. And so it's hard to see here, but these are actually double spaced substrings within each name field. The reason I want to know about that is so that I can get rid of them. You'll see why in a little bit this afternoon. So in first names, I only have 1 entry that has a double space somewhere in the name. Last names, I have 2 that have a double name, or sorry, a double space. So I want to get rid of those. And the reason will become obvious a little bit later. I want to leave the space, but I don't want 2 or more. So these 2 G subs are going to take any space plus more space and just leave a single space. And then the last bit here, I'm just going to trim any white space. So that's going to take, if somebody has a space in one of their name fields at the beginning of the character, so space John, I don't want that extra space there. And if they have a space after their name field, John space, I don't want that to stay there either. So that's all trim white space will do. It will not alter any spacing in between entries in the string. So if I have John Robert, that space between John and Robert will not be altered by trim white space. Okay. And then the last thing I want to know about spaces is how many of them there are. Okay, so what this is going to do is go through and just pull everybody out that has more than one space in their first name field. And I only get one case that has more than one space. Some people have one, but there's only one case that has more than one. So Melba and Sophia. I want to do the same thing for last names. And the reason again for this will become obvious when we start talking about linking people together. Last names, quite a few more, and this is pretty common. These could be multiple last names. So James Holloman, that could have been a hyphenated name that the hyphen's missing. Some names are multiple syllables separated by spaces. Obviously, I would get concerned if I did this and got somebody that had 35 or 40 spaces in their last name. I do have cases where I have 8 or 9 entries in a single name field. A person actually has 9 middle names. It's unusual, but it happens. So I'm pretty satisfied that I'm not going to have too much to do here, although that third sitting there is not a name. So I want to deal with that. Generally, I always check to see if there are digits in my text fields when there's not supposed to be. So this is a regex, right? We're going to look for a pattern that contains a digit, any digit, in the first name. Nobody. Good. Do the same thing in last names. We've got a couple. And this is sort of what we saw in the lecture. Okay, clearly this is a suffix that has to come out. James Holloman III. Clancy 2, Isaiah Clancy 2. Maybe that's junior. Possibly. Charisse Cell 22B is probably not right. What we don't know is whether or not those 2s should be letters or whether or not they're just accidental entries. In either case, we're going to remove them. This is where order of operations could become important. If we wanted to take off suffixes, we would need to change this 2 in Clancy to something that we could strip out before we just got rid of all the numbers, right? So just a simple G sub here. I want to turn them into Roman numerals just because it makes it clear to me that they're suffixes. So just subbing that 2, notice that it's the 2 at the end of the character string, not the 2s in the middle of Selby. And that third is just a simple replace. Anytime the character string 3RD appears, it'll get changed to 3 I's. Right? Now, if I actually go back and run digits, I won't see those 2 that we changed, but cell 22B is still there. Okay? So now, because I run into this all the time, quick little function to knock out numeric values in the remaining names. And it's just a G sub nested within a function to replace with no space. Again, if this is something you only do once, you could just write the G sub part. But I actually end up applying this to multiple fields in a particular cleaning exercise process. So I can apply it to last name, first name, middle name, address, hospital, city, all sorts of things. So here's the call. I'm just going to apply it to last name here because I didn't have any numbers in first names. All right. The suffixes that were there or created, there could be others. There could be juniors, there could be seconds and thirds that were already in the data. I typically don't want them. They create noise and some things I'm going to do down the road in my linkage process. And they're not that important to me. I'm usually dealing with small, young children, prenatal enrollment records, birth records, kindergarten, preschool, those sorts of things are the state systems I'm working in primarily now. So junior, senior shouldn't occur, but junior, the third, the fifth, it doesn't really help me at this point. But down the road, if we start getting records from adult systems, workforce development, and those sorts of places, then I'm probably going to want to keep suffixes so I can differentiate two people with the exact name who happen to be junior and senior. Currently, I have suffixes that occur quite a bit, and I don't want them in there. So here is a function that gets rid of them. A word of caution, this function has seen many, many iterations now to try and optimize it to catch everything, and it doesn't yet. There's one thing that's still a sticking point that occurs occasionally with this function, but generally it works pretty well. The idea is that it's going to go through and look for any sort of separator. So that could be a space, a comma, parentheses, quotation marks, a hyphen, and it's going to then look for those markers followed by a list of suffixes we provide. So if we run the function and load it, our call then is here. I want to just call the move suffix function, apply it to the data set, the last name field. I can do this to first names too. My list here is I'm only using the third and the second because that's all I have in these data. This list is expandable. So this could take on multiple values following these operators or these symbols. Order of operations is important. Remove the thirds before you remove the seconds. And so if I run that, we now go take a look at the data where we've essentially created a new variable. We now have a suffix variable at the end that only contains data for those people that had one. And again, later in the day, I'll probably get rid of this column, but it's useful to have down the road. So if I start getting folks that are generational, this is going to become a very important piece of information for me. The one downside I have with this function in its current form that I've mostly fixed, just not happy with the output of, is that it can find those two letters or whatever we give it following a hyphen and remove them. So I lose things like Smith hyphen Iverson as a last name if I put IV in this list. So that function is still a work in progress. Again, it doesn't happen too often, generally works. Worked fine here. Okay. Work in progress. Okay, so I've removed my suffixes. Next thing I want to do is get a handle on what kind of punctuation I have floating around in here. Some of it's important, some of it not so much. And so what I'm going to do is again use just a grepl to look for any punctuation in the name fields. I'm limiting the output just to their ID and first and last name columns just to minimize the output. This part's not necessary. And this C1 and through 3. It's just a column request so that we don't keep getting these huge rows of data when all I care about are those first 3 fields. So we'll click run. Quite a few people with punctuation in their first names. We typically expect hyphens, surprisingly more than I would have originally thought. A lot of folks do have hyphenated first and last names. Apostrophes, also pretty common. Nicknames being separated out by things like brackets. Nothing really odd. But some things we want to get rid of: diagonal slashes, So we'll want to clean all of that out. And then we'll want to do the same thing with last names. We have anything that jumps out at us there. So we get a few more cases, 86, and it sort of makes sense that you might have more hyphenated last names than you do first names. You might have split first names where there's 2 words, but hyphenated last names are quite common. And we scroll through those, just kind of get a sense of what's there. Commas, a little strange. Hey, O'Brien, we talked about that yesterday. Here it's somebody's name. Apostrophes again, separating syllables in names. Hopefully nothing dramatically wild, but sometimes you will just get strings of asterisks. At signs are not uncommon. There might be one in here. These are fun. We'll deal with those shortly. So some things we want to clean up and remove, some things we don't want to just delete. And so I definitely don't want to just get rid of a hyphen, unless I'm keeping a space there, but we'll talk about that here. Hyphenated names, I want to get rid of the hyphen to simplify some things, but I want to make sure that that hyphen is replaced with a space. I'm going to want to maintain as many spaces as I need to keep these separate name elements apart. This is real simple. It's a G sub. It's easy to apply, but I have to do it so much I wrote a quick little function to do it. It's called hyphen split. I should rename the function to something that's only 1 letter so I don't have to type hyphen split all the time. But it's just a simple G sub that I can then apply to first names, last names, or any other text fields. And what this is going to do is go in and replace the hyphens with a space, a single space in both first and last name fields. That should minimize the number of people who don't have punctuation in their last names and first names. Names with ST in them. St. Joseph, St. James, St. Clair, St. Carlson. These are not necessarily a problem, but they do create a little bit of a challenge for me down the road in my record linkage processes. And so this is just a tidying step. This is not something you necessarily would want to do. This ST period is not an invalid entry. But in this particular case, I want to get rid of the space between ST and the name. Again, that'll become a little bit more clear when we talk about record linkage and things like that. But all I'm going to do is sub out the ST period and just replace it with the ST, basically getting rid of the period and the space. Note that from your regex information that I'm starting only if ST is at the front of the boundary, and then I'm escaping the period, but followed by a period. And so I do that. And again, it'll become clear why I'm doing that in a little bit. The last thing I kind of want to look for in my name fields is anything that's not supposed to be there. So these are just ASCII code keys. It saved me a ton of time to actually spend 10 minutes and look these up one day. So just doing a grepl to see if any of this stuff is in here. And basically what this is doing, and I'm going to shorten it someday, is show me anything that's not an alphabetic letter that's uppercase left in these names. Okay. And so we might expect I still have some brackets, some parentheses, there's an asterisk, some slashes. Okay, I want to get rid of those. Last names. Oops, sorry. Okay. My last names, I have slashes again. But here I have some other interesting things. I've got some Latin letters or some accentuated letters. I don't want to get rid of those. I want to keep them there for now. Sometimes it depends. There's a decision in my work to make about what to do with those. It's, again, one of those works in progress. Not that they're invalid, it's just that there is inconsistency about whether systems use them. If I'm trying to line up a last name that is Yapon that has an accentuated O in it with Yapon that just has an O in it, I'm going to run into a little bit of trouble down the road. Currently, I like to leave them the way they are. You do make some system-specific corrections if they're defendable and obvious. Okay? So if we go back up and look at first names, somewhere in there, somebody has an asterisk, or sorry, an @ sign in their name. M@RQUIS. I'm guessing that was a typo for an A. I might be wrong. That might not be an A. If that's the person's real name, although I think most states prohibit symbols, as long as I correct it to an A and I correct it to an A in every other subsystem I'll deal with, I'm consistent. Not that I would go through correcting tons of things, but I've seen enough A's replaced by @ signs. Typically names like Aaron, you'll get A@RON or @ARON. Sometimes those replacements are pretty obvious. Again, be consistent. So I'm going to make that simple G sub replacement there. I want to fix that in my order of operations because the next step I'm going to do is get rid of all the other junk. Okay. So I have a function, short, sweet little function that's going to go through and look for alphanumeric characters. It's actually not alphanumeric, and get rid of them all. It's going to sub them all in to a no space or space situation. Okay, the default here is to keep the spaces if there is one. We can change that if we wanted to. So if we load that function, we want to apply that to both the first and last name fields. Separately, I guess I could have done it together. And if we were to go back up now to these two grepl commands, what we should see is a removal of all of that noise. We still have people here, but it's now limited only to the people who had an accented letter in their name field, which again, I said we wanted to keep in this situation. We should see the same thing in last name fields now. All the punctuation gone, maintaining only those names that had an accentuated letter. So, done cleaning up my names as far as I want to clean them up. I quickly want to reorder my columns around a little bit, which I now have to change on the fly because I created a new column. You guys did not. So, don't worry about this part. I actually created that second UID. So what I wanted to do initially was keep their CID and bring in the UID that's in column 6 that we created, make that the second column, and then keep first name, last name, and then jump all the way to 11, which is now probably 12, right? And then fourth and fifth columns were my gender and birth date variables. And now I want to go 7, let's see, 1, 2, 3, 4, 5, 6, 7. I don't want 7. I don't need the second UID. So you don't have to change any of this. Just me, hopefully. Make sure I got that right. Hey, I did. All right. Counting on a Thursday. So now, earlier, we got rid of somebody in these data that had the same initial identifier. Remember, May Leilani. We got rid of the extra entry for that person. Now I want to see if, by chance, we have duplicates in the data that have different IDs. And this happens quite a bit, actually, where a system identifier will be tagged to the same person, where they'll now have multiple IDs. Sometimes that's perfectly reasonable in a multi-record system or a multi-identifier system. Other times it's not. Like a student ID shouldn't be duplicated. An individual should have the same ID all the time. So what I'm doing here is I'm now just looking for any rows of data that are exact duplicates across columns 3 through 11. And remember, we just reordered some stuff, so that'll be their first name through the rest of the file, not their IDs, not the original one they had, not the one we generated. It's just everything else they have in that row. Okay. Whoops, sorry. What did I do? You should have gotten a duplicate. I'm not going to get one now. 10. Got rid of a comma. That's why. All right, so now I get a duplicate. You guys should have gotten this person too. You shouldn't have had to have messed with either of these lines. And what we've got here is somebody that had an initial ID in the system, CID, that was different. When we generated an ID for them, it's also different. Remember, that is unique. This is the same person. So this is different from our Meilani or our Leilani in that this is a different ID attached to the same person. It's not necessarily a duplicate record across the ID, but it's pretty compelling that it's probably the same person. That's not always the case. Again, this is a decision point. We might decide that these are two different people who happen to have very similar or exactly similar names and birth dates. It's much like that birth record example I showed in the slides. If we have any additional information to verify that this is not or this is the same person, we would want to consult that. Usually there's something in data systems that can help with that. Educational data, for example, I would now read in what school they went to, what district they were in, what grade they were in, all of those sorts of things to try and find any discrepancy in the two records. And if the records maintained an exact match across multiple columns, I would probably reach the decision that this was an accidental assignment of a new ID. Okay. So what I want to do here then is I'm going to keep one of them. And they don't, remember, they don't differ in any information past the ID numbers. Without any kind of timestamp or indicator of when these initial IDs C-6 or C-7 were assigned, it's arbitrary as to which one I'm going to keep. By default, running this next line of code will keep the first one. But if I had some sort of timestamp, I mentioned we might actually keep the latest one, because if this C716090 was assigned the following school year, that's probably the code they're going to show up with next school year. So we might keep that later one, a decision to make, again, based on the specific data system you're working in. So I'm going to drop one of them, which I have to change again, sorry, 10. Drop that. And then just to check, now I'm checking just based on that person's name, and I have that one line of data. Okay, so now I have no duplicates in this data set. I've cleaned the names, I've cleaned the birth dates as best as I can, aside from maybe those 2-3 years that I would delete. I've standardized my gender column, everything's ready to go. And here I would write out my cleaned demographic data file. You don't have to write it out if you don't want to, but that's generally the rough process I go through to clean a first swipe at data. Any questions on any of that? Everybody's happy? Again, not glamorous, but it is the reason why I'm excited when I get a new data system and get to play with the challenges.